Hello everyone. So my project topic is powertrain sizing for two-wheeler electric vehicle, in which I'll be sizing motor and battery using Simulink. So while designing an EV, the main important thing is to properly size the motor, battery, transmission for the need to be fulfilled to run a vehicle in a proper driving cycle and optimize the range, get a proper amount of energy to be used, and optimize the performance and meet the driving requirements. So there are different modeling techniques in which there is a backward facing model and there is a forward facing model. In backward facing model, we feed our drive cycle into the vehicle model, and into the vehicle model which goes to the transmission and to the engine, and engine or a motor which we can be used to find how much amount of power is to be provided to run in this particular drive cycle, and with that we can find the energy consumption. In the forward facing drive cycle, we just find these data and put it in the forward facing model, so as to check whether my sizing is proper or not, and then I can just verify whether the desired speed is equal to actual speed of the vehicle or not. So in the backward facing model is we have a driving cycle, we just integrate and get a distance and then differentiate and get a acceleration, and use this tractive effort formula, and using the velocity and acceleration, and then multiplied it with the driving cycle v, in which the v data is given, and then found the power which have a certain curve. And with the help of the power of the motor, we can just find the energy consumed, but to and the torque of the motor. But to do that, we have to find at what condition the vehicle is, either it is braking or either it is driving. So we find omega, and then with the help of conversion ratio of the transmission, we just find the omega at the motor, and if the omega is greater than 0 and the power is positive or negative, like if the power is negative, it is in regeneration mode. If the power is positive, it is in driving mode. So while the regeneration with the power flow will be opposite, and while driving, the power flow will be from battery to the wheels. And if the omega is 0, omega of the motor, that is angular speed of the motor, is 0, it means it's at stationary. So we just write the equations, and for the power by considering the efficiencies, and the energy consumed. When we find the energy consumed, if when the vehicle runs in the driving cycle, we find the energy consumed per kilometer, and when we find the energy consumed per kilometer, we can find the battery size and the battery capacity as per when we divide it by the voltage of the motor. So with this we can find every sizing. So I have written the code for this initially. I'll show that. So this is the inputs which I've used for all the models which have been created. So I'll be showing you 3 models, and so this is the pretty large code. So that's all the code, and these are the outputs we can see. So this is a driving cycle, this is the acceleration time. We can find this sizing of battery and motors, and we can see the curve, how it is changing, the power curve, the speed curve, the torque curve, and this is the SOC. This increases due to the regenerative braking. This is forward facing model, in which I found the data from the backward facing model and I put it into this like size of the motor, the amount of the battery, and everything like this. In this, the driving cycle is fed to the drivers, and which creates the PWM, which is being used to control the motor. The amount of current drawn is fed to the battery to find SOC. This motor will power the transmission, the gearbox, and then which is being fed to the rear wheel, because it's a rear wheel drive, it's a two-wheeler vehicle. I have chosen as Ather 450X, and then I have just found that the vehicle speed, now it must actually match with the driving cycle, then only we can say the sizing is proper. So hence it matched with the driving cycle. This is the actual speed, the blue one, and the red one is the driving cycle, inner driving cycle, which I have. And this is the SOC and the current from the battery and the voltage from the battery. And we can know the other method is the using the QSS library. So in this I have used the driving cycle fed to the vehicle, and then which gives us the amount of tractive force that is supplied to the wheels and through the gearbox, and which is being fed to the motor, which comes from the motor, and which in this the energy comes from the battery. So I have just connected all these things and found the this is the velocity, this is the battery SOC, this is the current, this is the energy, and this is the electric motor. So we can find that Ather 450 is having the maximum speed less than 80 km per hour. So we can see that while 80 km per hour, so the maximum, so it has to be around 800 to 1000 seconds. So while we consider this, the maximum, the power, average power is below, like around 2.5 or 3 kilowatt, and then the maximum is around like 4 kilowatts. So hence we can properly size the motor as per the need of the driving side.